Hello, I'm Tom English, and our lesson today is on quadratic equations. Quadratic equations are of the second degree. In other words, we have y is equal to x squared, and the standard form of the equation would be y is equal to ax squared plus bx plus c. And it's important to understand the relationship that A, B, and C have with the final graph of the parabola that all quadratic equations form. The first thing, if we look at this first example here, I eliminated the B, X, and C just so that we can understand what the impact of A is. When we look at the equation, we can tell right away, does it open up or open down based on the value of A. If A is a positive, then the parabola will open up. If A is a negative, it will open down. That's simple. Also, the absolute value of A determines the actual width or narrowness of the parabola. For instance, this is kind of the standard shape when X or A is equal to 1. But if we made A to a 3 or 4, the absolute value, the bigger that absolute value is, the narrower the parabola would be. Be something like that. And just the opposite if we had a fraction, for instance, maybe it was 1/4 x squared, or x squared over 4, then you would see this would widen out quite a bit. And again, the smaller it would be, the wider it would become. So just looking at the coefficient of x squared will tell you quite a bit about it to start with. Open up or down, narrow or wide. The second coefficient, the coefficient of x term, in the standard form we call that b. That is important because that'll tell us where the axis of symmetry is. And first of all, by the axis of symmetry, we mean the line that goes down the very middle of the parabola and splits the parabola into identical halves. Okay, so it's always going to be that shape, in that the right side will equal the left side. That means that every point is equal distant from the line of axis with its corresponding point on the other side. Also, the position of the axis depends on the b value. If there is no b, the axis of symmetry will always be the y-axis. But if we have an example here, a minus 2x, so b is actually minus 2. Well, that's going to shift that axis of symmetry away from the y-axis, and it's interesting in that it does just the opposite. For instance, if it is negative, then it moves it to the right, half of the value of b. So if b in this case is 2, it will move the whole parabola to the right, opposite of the negative, and it'll move it right one position. If this happened to be 10x, then we know it's going to move it over to the right 10 or 5, half of the 10 or 5 positions. If it happened to be a positive 2x, then we say it's going to move it to the left. So kind of hard to see in this small diagram, but that one would be more in line with those, and you can see the difference in the two. Same shape, but where its line or axis of symmetry is depends on that value of b. The final c, and if you think about c is just a constant at the end, and what c is going to do is going to move the entire parabola up or down, depending on whether it's a positive or a negative. If you think about it, no matter what's going on before the c, all that's doing is adding or subtracting from the final value of y. So that moves the entire, if it's a positive, it will move the entire parabola up. If it's a negative, it'll move it completely down, or proportionally down. Hopefully you can lock in on this. It's important, and you're going to find many questions on tests throughout your math career of what is the shape of this parabola, what direction does it point, so forth. And it's all based on the coefficients in the equation itself. There's something called the quadratic formula that I put at the end of this lesson in the write-up on the website. We'll attack that. One of the things we're going to do in the next lesson is factoring, and we'll attack that at that time. But you might want to look at that because it's interesting how they get to that formula, and it's something that you're going to have to lock in on. Y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. That's a mouthful, but I had to learn it 50 years ago, and I'm sure you're going to learn it quickly in the next year or so. Thank you.